So this is chapter 1.3 for Algebra 1. Again, I'm not going to give a lot of time to write this down because you guys can watch the video and pause it or get them out of the book. The first thing we should talk about was what does it mean to be an equivalent expression? Equivalent expression. Equivalent means equal. Expressions mean the things with numbers and variables. So what it comes down to is that when you have equivalent expression, means that one expression and another one are the same. So they're equal. I mean, that's kind of the big thing here, equal. So equal things. We can almost get to the point where this is starting to become an equation. But what we're really doing is just simplifying. I think most of us would understand that 4 over 2 is equal to 2. Yes? Those are equivalent expressions. One's the simplified version of the other. And so what we have here is that we have properties of equality, properties of equalness. We have something called a reflexive property. We have a symmetric property. We have transitive property and substitution property. These are all things that you guys will have to use. And what do they mean? Well, in words, reflexive property. Any quantity is equal to itself. Well, that kind of makes sense. A is equal to A, is what it says. 5 is equal to 5. 4 plus 7 is equal to 4 plus 7. Not a big deal. You guys all know that. The symmetric property says if one quantity equals a second quantity, and a second quantity equals the first quantity. Oh, basically you can switch the order. If A equals B, then B equals A. If 8 equals 2 plus 6, well then 2 plus 6 equals 8. Duh, right? That makes sense. We've been using that since we were in first grade. Transitive property. Now this one's an interesting one because it's very helpful if we understand that if two things are equal, and one of those things that are equal to something else, well then the two ones that are not connected also are equal. And that's what it shows here, without having to go through all the words. If A is equal to B, and B is equal to C, well then A has to also equal C. If I have the same amount of money as Joe, and Joe has the same amount of money as Rio, well then I and Rio have the same amount of money. Yeah? Makes sense. We all have done that before. And the last one is substitution, which I think we use quite often. The substitution is that a quantity may be substituted for its equal in any expression. Guys, you do this every day you use money. Hey guys, or anytime you guys went to the bowling alley with your parents, I remember this as a kid, and you go ask them for $1 to go play the video games, or you go out to eat and you want to get that little gumball for 25 cents, and they only have $1, you go get change for it. The change is equivalent to the $1. 4 quarters for $1. 20 nickels, right, for $1. They're equivalent. Everybody would be okay with me going and say, hey guys, I have 5 ones, can anybody give me a 5? Everybody would be okay with that. But if I said, hey guys, I only have 4 ones, can anybody give me a 5 for it? Not too many people are going to be happy with that, okay? So you can substitute things that are equal. So again, if we have the words here, if A is equal to B, then if there's an A somewhere, I can put a B. Or if there's a B somewhere, I can put an A. Works out fine. Again, that's how we check our solutions later on. When we solve an equation, you'd always substitute it back in. Now, one thing I will say that goes along with this. Anytime you are using substitution, I want you to use those. And what are those? On the bottom there. Parentheses. If I'm going to substitute a number in, I want parentheses used. So, if I use their example, I want to see that there's parentheses around the 11. Because what happens is that sometimes your variable that your value for the variable is negative. And when you substitute in a negative number, some people think it's a minus sign instead. or they completely ignore the fact that that negative's there, and then they get the problem wrong, even though they did things right. So be very careful on that. Okay, so now we're going to go to addition properties. We have the additive identity and the additive inverse. And so it says that if you have any number, the sum of A and 0 is A. Basically, additive identity. Something that you can add to any number and get that same number back is 0. If I add 0 to anything, I get what I had originally there. That's why it's additive identity. Additive inverse means add its opposite. And when you add opposite numbers together, you get 0, guys. And there's examples of all of these. See, the nice thing about it, years past, before I got the iPad stuff, I would have wrote all of that on the board. We'd still be on the first slide, guys. And you guys wouldn't be able to read it. So, going to our two examples there on the bottom. We have 7 times the quantity of 4 minus 3 minus 1 plus 5 times the fraction of 1/5. This is the major part of your homework. Using the properties on all the boxes so far, and a couple of them coming after for another one later on problems, you need to evaluate, which we did yesterday. That's no different than what our homework was, right, on order of operations. But now, every time you do a step, you need to tell me what you did. Basically, name the property. Oh, that was additive inverse in that step. It was the associative property. That was the substitution property. And this is where I said, a lot of times it just kind of defaults to the idea of substitution. Okay, before we get to the examples, let's do this first. I'm just going to do all the properties. That way, everything's fair game, and you guys know what they are. So we can go to the multiplication properties as well. Basically, we have multiplication identity. Any number times this is back to its original number, and that is 1. And A times 1, or 1 times A, is A. That's associative or commutative? Commutative, right? Commutative property. You can switch the order. Multiplication property of 0. 0 times anything is 0. We know that. And the multiplicative inverse. Now, an inverse of multiplication is actually got a better word. Is multiplying by its reciprocal. So I'm going to put underneath that for that one. Is a reciprocal. So the reciprocal, multiplying by its reciprocal. So that means if A over B is your number, you multiply by B over A, the B's cancel, the A's cancel, you get 1 over 1, which is 1. That's what happens. No matter what, it should always happen. And then you got the commutative property and the associative property. I kind of hinted at it already. This one's a little bit fuzzier. The commutative property, guys, here just states that you can multiply or add numbers in any order. So if I have two numbers, 4 plus 8 is the same thing as 8 plus 4, yeah? 7 times 11 is 77, but so is 11 times 7. The order switches, it's perfectly fine. The associative property, guys, just means instead of just two numbers, it means groups of numbers. And if groups or numbers are all added, I can group them in any way I want. That also means for multiplication. So if there's two numbers in a large group that can add to tens, think back to the day when you first started adding. Your whole idea was to get groups of tens or hundreds. When multiplying, usually it's the same thing. How can I find something that's smaller that I could use? Like 4 times 3, which I know is going to be a 12. Or get the 5s together to get 25. Those types of things. So those are all things that you guys have learned over the years. Now there's some names for those. What it comes down to is you can group them or multiply them in any order when it's all multiplication or all addition. That's all the properties. So what we're going to do is we're going to go back to those two problems that we had. And now we can evaluate and use all of our properties at our disposal to make this happen. Order of operations tells us to do what first? Parentheses first, yes? So 4 minus 3. Is there any particular property that happens there? First of all, what is 4 minus 3? It's 1. I'm going to leave everything else the same, especially since I am trying to name my property. So the property of that happened here? Rich? No, there's no property that says when I subtract 2 consecutive numbers to get 1. So, I'm going to default, going back, like I said, to substitution. And so at the end of this one, I'd put substitution. Next step, next thing I want to do, name something. Give me a step. For what? 7 times 1. Okay, 7 times 1 is 7. So minus 1 plus 5 times 1/5. That's a multiplication. Yes, it's something multiplication, but which one? That is a property. Where is that one? Here. Where is that one? Luke? Yes, it's a multiplicative identity. So multiplication identity. Does everybody kind of see I'm doing one thing, telling me what I did? What property? The next thing I have to do, according to order of operations, what's it? Where? 5 times 1/5, and 5 times 1/5 is? It's not 5. Oh, it's 1. This one is the multiplying inverse. Anything times its inverse when multiplied will equal 1. And then, once you kind of get this to the point where you're just adding and subtracting, 7 minus 1 is? There's no property for that necessarily other than the fact that I am exchanging 7 minus 1 for 6, so we call that substitution. You get 7 because 6 plus 1 is equivalent to 7 using substitution. So as I said, substitution comes up quite a bit. The ones that you really have to name are the ones where you can see that we're definitely using an addition identity or additive inverse or something on those lines. Then when you don't use substitution, we kind of name what it is. I'm going to give you guys a couple seconds, maybe a minute. I want you to do the second one on your own. Okay, first thing I want to do is what? Doesn't have to be necessarily the first thing. Fritz? Divide 15 and 3. Okay, sounds fine. So 7 times 1/7 plus 6 on the outside. What is 15 divided by 3? 5. And what do we want to use as our property? I think it'd just be substitution again. We don't have one that says, hey, if I divide it by 3, right? Okay? Something else? As long as it's mathematically legal, we're going to go with it. What is it?
Multiply 7 and 1/7.
7 times 1/7 to get what? We're going to do this part. 1 plus 6 times 5 minus 5. What property was that again? Inverse? Multiplication inverse, multiplicative inverse. When you multiply their inverses together, you get 1. And next, someone else. Someone help us out. Clark?
5 minus 5 is 0.
Yeah.
You're doing 6 times 0, and that's the...
Hold on. We've got to do one step at a time. What property did you just use? Not going to use substitution on this one, am I? Additive inverse. When you add something that's opposite, you get 0. And then, yes, 6 times 0 is 0, and that's a property. It's a 0 multiplication property. Notice I'm abbreviating these things. I'm not going into the whole name and writing it all out. And 1 plus 0 is 1 because that's the additive identity. Additive identity. It's good to go, right?
Right.
Okay, the last thing I want you guys to do is just evaluate this again. Tell me some steps that you're using. Here's the thing. All of these numbers are multiplied. I can multiply in any order I want. That would be what? Associative property, right? I can group them together. So, using the associative property, can I do this?
Yeah.
And what's 5 times 7?
35.
It's 35. And then times 8. This is the associative property. Watch how you abbreviate that, guys. And then 35 times 8?
280.
Associative property, and what was it?
280.
280. That one would have to be substitution. Here's the thing, though. Could I have done instead 5 times 7 times 4 times 2? Could I have done 7 times 4? So it would be 5 times 28 times 2. And then I could do 5 times 28, which would be what? Probably like 140. And 2 times 140 is 280. They come out to be the same. So it doesn't matter. The associative property, commutative properties of multiplication or even addition work. Homework, lesson 1.3, page 19, 9 through 48, every 3. Have a great day.